Hi everyone. So we have the following problem. 4 equal charges are located at the corners of a square of side 10 centimeter. The charge of each one of them is 2 microcoulombs. The question is to find the magnitude of the electrostatic force on any of the charges. Since all of the charges are identical, the distances are the same, then the force is going to be the same on each charge due to the other 3 charges. So let's take one of them. I'm gonna take this charge here and study the forces on it. So we start. This charge exerts a repulsive force on the 2 microcoulomb. I'm gonna call this force F. This charge here will exert also a repulsive force on the 2 microcoulomb, the same force F. And the last charge is going also to cause a repulsive force on the 2 microcoulomb, but this repulsive force is going to be smaller than F. I'm gonna highlight it with green. Why it's going to be smaller than F? Because the distance is larger. If each side of the square is 10 centimeter, then this side, the diagonal, is going to be 10 radical 2. Now let's find F, the red force. So F is K multiplied by Q times Q, because they have the same charge, so it's a Q squared, over the distance between them, which is R squared. So we substitute 9 times 10 power 9. The Q is 2 times 10 negative 6 squared. The distance 10 centimeter, so it's 10 multiplied by 10 negative 2 squared. So we do the math here. So F is going to be, we can do it mentally for sure, but let's directly use the calculator. So we have 9 times 10 power 9 multiplied by 2 times 10 negative 6 squared over 10 times 10 negative 2 squared. And we will get 18 over 5, so it's around 3.6. Alright, so it's 3.6. So F is 3.6 newtons. Now, we have 2 red forces, F and F. So we know that the result of F and F is going to be some force between them in the same direction of the green force. So this violet force, let's say, it is the sum of F and F. Okay, I'm gonna call it, let's say, F prime. So how do we find F prime, the resultant of the 2 red forces? By using Pythagoras theorem. So F prime, because again, just to explain it, so we have this F and we have that F, so that is F prime. This is F prime. So F prime is found by using Pythagoras theorem. So it's radical of F squared plus F squared so it's a square root of 2F squared, which is F radical 2 for sure. So F prime is going to be 3.6 radical 2. So 3.6 multiplied by square root of 2, and we'll get around 5.09. 5.09. Now this is F prime. Let's find the green force F. So the green force F is also going to be K Q squared over the distance r squared. So k is 9 times 10 power 9. Q also 2 times 10 negative 6 squared. And the distance now, it is 10 radical 2. Right? It's 10 radical 2 centimeters. So 10 radical 2 times 10 negative 2 squared. So since the distance is multiplied by radical 2, right? So when you square it, you will get half. So it's gonna be half the value of the red force. So F will be half the value of the red force. If you do the math, you will see that you will get that answer. So it's going to be 3.6 by 2, which is 1.8 newtons. All right, now F net, if you look clearly at the figure, F net is the sum of the purple force and the green force, because the purple force is simply the result of the two red forces. So F net will be the purple force plus the green force. So F net will be the purple force, which we called it F prime, and the green force, which is F. And hence we are going to get 5.09 plus the green force, which is 1.8. So it's around 6.89 newtons. 6.89 newtons. That's the total force. Thank you for watching.